This is Shane Picard with another geometry lesson. Today we're talking about circles and arcs. Before we get into talking about arcs, we need to define some things within circles. So we'll start with the circle itself. In a plane, a circle is a set of all points equidistant from a given point, and that given point is called the center. Here's an example. We have this circle here. A circle is actually a set of points. There are an infinite number of them, but they're all equidistant from point P. So if we were to draw in all those points that are equidistant from point P, that is what we call a circle. It's actually the set of those points. The circle is named by the center, point P in this case. We also have what is called a radius. The radius is a segment that has one endpoint at the center and one endpoint on the circle itself. The congruent circles have congruent radii. So if I have two circles that are congruent, by definition, their radii must be congruent as well. The diameter, most of us are familiar with the diameter. Here, there's the diameter AB. The diameter is a segment that contains the center of a circle and has both endpoints on the circle itself, points A and B in this case. Central angle is an angle whose vertex is the center of the circle. So in this example, there's a central angle CPA or CPB. Those are central angles. An infinite number of them that can be drawn in here. They all would have their vertex at the center P. Think of a pie chart. Speaking of a pie chart, here's one right here. One of the things we want to be able to do is measure or determine the measure of each central angle in circles. This example asks us to find the measure of each central angle. So let's just do one example, but let's look at this work down here. It's 20% of the circle. This is a pie chart. Find that this is 20% of the circle. We're asked to find the measure of the angle. Pretty easy to do. We know that 20% really means 20 per 100. So 20 out of 100 parts are in this particular slice of pie. And we know that when we talk about angles and measurements, there are 360 parts total. We want to find out of those 360 parts, or 360 degrees, how many of them are in this slice of pie. So we just set up a proportion, and then we simply solve by cross multiplication. It may be easier to reduce this fraction on the left down to 1/5. May make this a little bit easier to do that. And so we end up with 5 times x equals 360. Divide by 5, divide by 5. X equals 72 degrees. So this angle here is 72 degrees. And we could do exactly the same process to find any of these other central angles. When you talk about arcs, definitionally, an arc is a part of a circle. Pretty straightforward. So if I look at this circle down here, maybe I want to talk about this part of the circle. That's an arc. Or maybe I want to talk about just this part of the circle. That also is an arc. Any part of the circle is called an arc. A semicircle is half of a circle. It is a type of arc. It is an arc of specific measure. And you can see here that a semicircle is measure 180 degrees. So this is a semicircle from T to S. And this is a semicircle from T to S. Which brings us to a slight issue with respect to naming. When it comes to naming semicircles, we always have to name it by 3 points. If I simply said semicircle TS, you wouldn't know if I was talking about this one or this one. We name it by reference to 3 points, the middle point being some point on the semicircle. In this case, semicircle TRS is this one. A minor arc is smaller than a semicircle. So if we were to come over here and look at this arc RS, that is the minor arc RS, we name a minor arc with reference to 2 points, its endpoints, R and S in this case. The measure of an arc is always the same as the measure of its corresponding central angle. So if we knew, for instance, that angle RPS had the measure 120 degrees, then arc RS has measure 120 degrees as well. And that is true whether you're dealing with a minor arc or a semicircle or a major arc. A major arc is greater than a semicircle. Its measure is 360 minus the measure of its related minor arc. So if we come here and talk about arc RTS, that's this arc. It is a major arc, and its measure is 360 minus the measure of this angle, because the measure of this angle, of course, is the measure of this arc up here, the minor arc. Notice that major arcs are always named with 3 points, and minor arcs are always named with 2 points, and that's really what tells us the difference. So if I say, for instance, arc TR, well, then you know I'm talking about this one. If I say arc TSR, you know I must be talking about this one. So minor and major by name are distinguished by the number of points that we list. Identify the following in this circle. Minor arcs. How many minor arcs are there? There are 4. There's one here. Assuming, by the way, let's assume that this is a right angle. 2, 3, 4. That is arc AC, CE, arc ED, and arc DA, all minor arcs. What about the semicircles? There are 4 of those as well. Semicircle CAD, ADE, DEC, CA, 4 semicircles. In the major arcs that contain point A, we have arc ACD, that's a major arc. Arc CEA, that's a major arc. Arc EAC, that's a major arc. And arc DCE is a major arc. So there are 4 major arcs that contain point A as well. Sometimes you need to be careful to look for all those different combinations. By the way, those arcs could also be named with the letters in the reverse order. It would still be perfectly fine. Just like the naming convention on segments or lines or angles. Next, we need to talk about adjacent arcs. Adjacent arcs are arcs of the same circle that have exactly 1 point in common. So if I'm dealing with one arc here and another arc from that same point in the other direction, then those are adjacent arcs. Arc addition postulate is important to keep in mind. It says the measure of the arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. So for example, here we have arc BC. It is adjacent to arc CD. We find that we have central angle BOC, which is 32 degrees. So the measure of arc BC is 32 degrees as well. We also have central angle COD, which is 58 degrees. So the measure of arc CD is 58 degrees as well. And we can add those 2 together. So the measure of arc BD, and by the way, we always put a little arc over the top of the BD so we know we're talking about an arc. The measure of arc BD is equal to 32 plus 58, and therefore it's equal to 90 degrees. Talk about circumference. Most of us are probably familiar with circumference already. Circumference of a circle is the distance around the circle from a single point all the way around and back to that point again. That is the circumference. It's similar to the perimeter of a polygon. The number pi is the ratio of the circumference of a circle to its diameter. Notice that this is a definitional statement. We're not saying that pi defines the circumference. We're saying that the circumference compared to the diameter defines pi. A lot of times we think of that backwards. If we take the circumference of a circle and we sort of quantify it, and then we compare that to the diameter, in every circle we'll always find that the comparison yields the same ratio, and that ratio we define as pi. But if we take this definition of pi, that pi is equal to circumference divided by diameter, that's the definition of pi. We can do some algebra on that definition by multiplying both sides by d, and we end up with circumference equal to pi times diameter. And in fact, it turns out that that's a good rule for us, and it's the way that we typically will calculate the circumference of a circle. Circumference of a circle is pi times the diameter. I remember is irrational. That is, it is a non-repeating decimal, and so we use 3.14 to approximate it, although that is not an exact value. Certainly close enough for most of our purposes. Circles that lie in the same plane and have the same center are called concentric circles. So think of a bullseye on a target. If I have a circle and another circle around that, a circle around that, a circle around that, and if the centers are all the same, we call those concentric circles. Talk about arc length. The measure of an arc is in degrees, while the arc length is a fraction of a circle's circumference. In other words, while the measure of an arc is stated in degrees, the length is generally stated in customary units for distance, feet, inches, miles, whatever the case may be, meters. And so there has to be a way to calculate arc length. Here it is. Length of an arc of a circle is the product of the ratio of the measure of the arc and 360 and the circumference of the circle. What does that mean? Let's take a look at an example and see if we can figure it out. To find the length of the arc shown in red, we want to know the actual distance around the arc from x to y. That's what we want to be able to figure out. The first thing we need to know is, what is the measure of the arc? Well, the measure of an arc is always equal to the measure of its related central angle. So in this case, we have arc xy, and so therefore we need to look at angle xoy. You see that's a 90-degree angle, and so we know that the measure of this arc is 90 degrees. So the first thing we need to do is set up a ratio of the measure of the arc, 90 degrees, and 360. That's the very first thing we need to establish, and that's this piece here, the ratio of the measure of the arc and 360. And then we multiply that by the circumference of the circle. The circumference of the circle, you may remember, is pi times diameter. So in this case, it's pi times 16. Okay. When we've set this up, we can actually reduce this quite a bit. We can simplify it, and that's not always the case, but in this particular problem it is. 90 over 360, as you can see from the circle itself, is actually 1/4. We need to multiply 1/4 times pi times 16. Well, 16 divided by 4 is actually 4, so this is equal to 4 pi. That is the answer, 4 pi inches. Answers typically are stated in one of two ways. They may say leave in terms of pi, which would be 4 pi, be a perfect answer. Or they may say round to the nearest tenth or nearest 100. And if that's the case, we would simply multiply 3.14 times 4, and we would get an answer. 12.56, I believe, is that answer. 12.56 inches. Either way. Let's then talk about congruent arcs. It is possible for two arcs of different circles to have the same measure but different lengths. So if we look here at circle O, there are actually two circle O's here. They're concentric. Here's one. Here's the other one. And if we focus for a moment on the angle here, angle COD, cash on delivery, angle COD, you'll find that there is an arc here on the inner circle and an arc here on the outer circle. Those arcs both have the same measure, but they both have different lengths. And you can imagine that the bigger the circle gets, the more extreme that difference will get. That arc will get longer and longer, even though it has the same exact measure. Likewise, as you go in toward the center, a circle in here would have a very small length on an arc, even though it has the same measure. On the other hand, it's possible for two arcs of different circles to have the same length, different measures. So if I look at the circle here on the right and consider this arc length here, and I compare it to a semicircle over here, this arc length here, I'd find that the two arcs have exactly the same length, even though they have different measures. This one is 90 degrees, and this one is 180. Two completely different measures, yet the same length. So neither of those situations present congruent arcs. In order for arcs of circles to be congruent, they must have the same measure and the same length. Well, how do we get that? Well, we only get that when we're in the same circle or in congruent circles. So for instance, in this circle here, if I were to extend these lines this way, like this, bring these and form diameters, we know that by the vertical angles theorem, these two angles must be congruent. Therefore, this arc is congruent to this one up here. So if in the same circle or congruent circles, if they have the same measure, then they'll also have the same length, and therefore they will be congruent. And that's all we have for today. There are quite a few new words in this lesson. Make sure you write those down. Make sure you memorize the definitions. It's important that you can understand those so that we can have a meaningful conversation. Be sure to work through a few review problems, and as always, if you have any questions, send me an email.